Yes.
Yeah. So first of all, good morning. I'm Alaa. I'm Sales Director for Dash Control System. It's my pleasure to meet you today. Actually, it's a wonderful day. So our partner Comsys from Swedish, Mr. Paul, he joined us, and Ms. Rafael also she joined us today. We have now a discussion webinar regarding the power quality Comsys from Swedish ADF technology, active dynamic filter. And it's a pleasure today to have this discussion, technical and to increase our knowledge regarding the new technology or the high advanced technology regarding the active dynamic filter. In a brief, I will try to have a presentation about Dash Control System, and then we will let the stage to Mr. Paul. He will start his presentation. I'll just make share for my screen and to have introduction about Dash Control System. So Dash Control System, it's your engineering partner. So Dash, we are 20 years experience. We are established in 1999 in Saudi Arabia. So we are in Saudi Arabia. And our field, we are focusing on industrial control system, power quality and energy saving electrical panel component. And our main business, we are focusing on the trading and solution. And of course, our slogan is your engineering partner. Dash Map, our headquarter is in Riyadh. We have a headquarter, showroom, and 5 distributors. Also, we have a good number of system integrator, sales engineer, and technical support. Also, we have our branch in Jeddah. We have showroom in Jeddah, 3 distributors, system integrator, sales engineer, and technical support. Also, Al Khobar, also we have showroom and 3 distributor and sales engineer. Around the kingdom, also we have distributor and system integrators. How we are acting on the sales? We have sales channels. We have direct sales engineers. They are contacting directly to the customer. We have showrooms, and also we have component distributor, telephone sales, call sales engineers, and online sales. We have www.dashcontrol.com shop. And as I mentioned, we have 2 main segments for business, trading and solution. In trading, we are focusing on wide range of applications like motor drive, medium voltage and low voltage variable frequency drive, and soft starter. And power quality, we have power factor component like capacitor and reactor and power factor controller. In automation, we have also a range of PLC, HMI, SCADA system. And for ATS controller, auto transfer switch, and generator starter, we have controller like a dual controller, ATS controller, and synchronization controller. For solution, we are focusing on energy saving solution and power quality. In power factor correction, we are working on low voltage and medium voltage power factor solution. So we provide complete solution from study up to implementation, and also we have full facility for manufacturing, installation, testing, and commissioning. Also on voltage stabilizer, we have range from 1 kilovolt ampere up to 6,000 kilovolt ampere. In solution, also we have temperature monitoring system and power and energy metering system. So we provide smart metering system with complete facility like monitoring the metering by software. In energy and power quality, also we have oxygen sag. It's the optimum solution for the sag, voltage sag. So it's a reaction in 3 milliseconds. And of course, today our guest, our company, our partner Comsys, we have active dynamic filter ADF. It's one of the best technology in the world regarding the harmonic compensation, resonance, and also we will have more detail about it today. So this is a brief of some of our project. We are focusing on energy saving solution with Starsheet, and through the ISCO company. So we are partner with a lot of companies. We supply materials, we make installation. We give full facility like engineering study and also implementation for solution. So we did a lot of project for King Abdulaziz University, Prince Sultan Military Center, Ministry of Interior, and also a lot of project. We are proud that we did a lot of energy saving solution by metering VFD power factor correction with ISCO company for Tarshid. And also in the government sector and industrial sector, we are superior in the solution of power factor correction, more than 20 years of experience. And also regarding the solution for automation control like soft starter or VFD, also we did a lot of projects like Saudi Irrigation Organization, and also Zahid Group, Al-Suraya, Al-Munajjim, National Food, and wide range of customers. That's brief about Dash Control. I'm happy that you joined me, and we will let the stage now to Mr. Paul. So thanks again, and we appreciate your time. So now for more detail about Active Harmonic and ADF solution, Mr. Paul, he will have the stage. Thanks a lot.
Thank you, Alaa. Thank you very much. So I will take the floor now, and I will present for 1 hour. And I will take you through a brief of our solutions on Comsys and the power quality. With me, Rafaela, she is our marketing manager here. Just will be in the webinar. So I hope my screen is visible right now. Yeah. Okay. Yes. So hi from Rafaela.
Hi.
Thank you very much. So we will not waste time, and we will take the presentation forward. Good. So as Alaa, thank you very much for joining today for this presentation. Thank you, Alaa. Thank you, Dash Controls, for organizing this. Dash is our official partner for Comsys solutions in Saudi market. And my name is Paul, he already introduced, and I'm the Global Business Manager for Comsys. I'm based in Sweden, along with our team in headquartered. We are a Swedish company. So if you wanted to follow us, know more about Comsys solutions, you can follow us on LinkedIn. We have our Comsys page in LinkedIn. You can connect me on LinkedIn, my mobile, my email, all contacts are here. And we have also Comsys channel in YouTube, where you will find the power quality, various topics, and harmonics being the prime topic for us. A brief of the company. It's a Swedish company. We are headquartered in the city called Lund. It's a southern Sweden, and it's a 20-year-old company. We started this technology called ADF, Active Dynamic Filters, long back, 2 decades back. And this complete product of ADF, Active Dynamic Filters, are engineered, developed, and manufactured and type tested in Sweden. And we supply globally to all the companies around. For KSA, we have our partners, Dash Controls, who are completely trained, and we take our product through them, and they take care of the sales and service support in the region for Saudi Arabia. We launched this product very, very long back. You know, when the market was not even talking about active solutions, we only talk about active solutions. So it's a very niche company where we focus only on power quality, unlike other companies who has many solutions like switchgears or drives, and power quality being a small portion of it. But this is our bread and butter. Day in, day out, we talk about harmonics, power quality. So we have a very good know-how of the solutions. We make very robust solutions. We cannot fail on the only product what we make. So we have done a lot of R&D on the product. And today we are spread across around 50 countries. So for any queries regarding, you may please get in touch with Dash Controls or me, and we can discuss in detail after this presentation. Maybe if you wanted to have a project support or more detailed discussion on your power quality subject on your factory or on a new project, we will be available later on to take a discussion. A brief about us. So we are here headquartered, the yellow block, it's Sweden. We are here. Our manufacturing is also here, and we cater to entire Europe, Asia, Southeast Asia till Australia, New Zealand. And we also have a setup, a factory and an office in US for the United States market for the US. So this is in Atlanta. So we have two manufacturing units, Sweden and US, and we have partners wherever you see in blue in color where we are spread across today. You name any applications, we are proven in that because we are here with this product for almost 20 years now, and we have systems running more than 10 years in many fields, even in Middle East. And you name any applications like marine, energy, water treatment, industry, data centers, we are quite strong there. So we know the subject what we are talking about, and we have proven in all kinds of applications in this kind of industries. When you talk about industries, we talk about any kind of industries like the steel or cement, metal, mining, car manufacturing. Any kinds of industry comes under that sector, and all other segments where we have a wide range of products to cater to all these segments. Yeah, a short client base. Just a brief, you have an option on this platform where you can ask questions on the chat, and we will see whether we can answer it today, or we will connect you separately and you will get the answers. You also have an option on the right side where you have some handouts. You will find this presentation there. You will also get a brochure. You will also get a presentation of dash controls, so you know what to contact and whom to contact. And if you do not find any details there, just write it to us. This is a brief of our client base. To be focused on Middle East, we are becoming more and more engaged on Middle East projects at the moment. So we have engagements on many projects across Middle East. We are a part of many prestigious projects under execution right now. We have also installations which are more than 10 years old in Middle East in various district cooling plants and various other steel and oil applications across Middle East. We can discuss that separately when we have more discussions forward. Yeah, so today you are here to learn a little bit about harmonics and power quality. So I will go to the subject right now. So the power is not perfect. So, we are all talking about an alternating current, AC current. In Saudi, it's 400 volt, 60 hertz. So the normal three-phase AC current is a clean sine wave. What you see here is the blue wave is your clean sine wave. And this is what you are expected to give it to your machines in your factory, or your drives, your PLCs, your coffee machines, whatever you run under your transformers. This is expected to have a clean sine wave. Now, when you run your loads, for example, few years back, you start the motors with respect to direct online starting or star delta starting. Then the later part of 2000s, the soft starters were introduced. These kinds of loads are called the linear loads. And when you run the motor with these kind of starting methods, the motor is nothing but an inductance. So the motor creates something called as the reactive power, inductive reactive power, because it's a winding, it's an inductance. And to counter that, you put a capacitor bank on the main PCC, point of common coupling, and this is where you stabilize your power factor to unity or greater than 0.9 and things like this. Is the normal practice. But the moment you change your starting method to a variable frequency drive, of late what we see is more and more of variable frequency drive starting, because it gives you a lot of energy saving, which is very important in industry perspective. So when you start the motors with respect to a variable speed drive or variable frequency drive, you no longer have the problem of power factor, because it gives you a very good power factor indeed. But you will find something called as harmonics, which is generated in the multiples of your fundamental frequency. So in Saudi, the fundamental frequency is 60 hertz, but you will find currents which are generated in your multiples of fundamental frequency, which is in 120 hertz, 180 hertz, 240 hertz, 300 hertz. So when you say 300 hertz is the fifth multiple of 60 hertz, and we call it as fifth order of harmonic. So these currents which are formed on the multiples of fundamental frequency are called harmonics, and these currents gets added to your total RMS current. And what you see it on the RMS current includes this harmonic currents, and your wave, instead of looking something like this, may look like this, a distorted wave, depending upon the severity of the harmonics which is created by the variable frequency drives or other nonlinear loads in the network, which are quite common today. Right, and you are giving this wave to your machine instead of this wave, and you know, when you give an improper wave to your machine, what happens is you have problems in your future, like the failure of the systems, poor efficiencies, taking more time for productions, it fails before the warranty, the lifetime reduces. These are many drawbacks what will happen in your network when you have such systems. So in harmonics, you have two important things. You have the current harmonics and you have the voltage harmonics. So it's generally denoted by THDI or THDU. U is nothing but the voltage and I is the current. So you can also call it as current harmonics or current distortion, or voltage harmonics or voltage distortion. This is quite important to know after you work on a VFDs, or of course it gives you energy saving, but as a byproduct you get the harmonics. Like other loads like EC fans today, LED lights today, or kind of rectification loads, non-AFE UPS can generate this kind of harmonics. And it's important to know that there are two important components in harmonics, because there is current harmonics and also voltage harmonics. And we all know that the current is always proportional to the voltage, so it's related. So if the current harmonics reduces, the voltage harmonics can be reduced proportionally if it's created by the load. Now you have to understand the differences between these two. If you have high current harmonics, it's basically affecting your transformer. You will have increased transformer losses and heating, reduced transformer life, cable losses and heating, tripping of the breaker. These are the main things which will happen. So it will basically going to the source side. So that's why you basically mitigate this harmonics at the source, at the point of common coupling or the PCC. On the other hand, you should also know that when you have a high voltage harmonics, the problems what you can have is very increased losses on your nonlinear loads and linear loads. This can lead to an equipment malfunction or a failure. So if in your plant, if you find there's something failing, then there is immediately, you should not think about current distortion, but on the other hand, you have something to do with the voltage, which is failing your systems. So there are different ways of analyzing your problems in the field, but this is a common thing what you should understand. If you address the current harmonics, maybe it will not address your failures. So these are the two variants of harmonics what is present. Talking about the power quality, as I said, Comsys is a very niche company. We focus only on power quality, and this is our bread and butter. This is our subject altogether. At any moment we talk about this subject. So if you see the power quality problems, what you can see in the whole network, these are the typical ones what you can see. So in harmonics, you can see extreme harmonics on voltage or current. You can see harmonics beyond certain kilohertz, like beyond 2.5 kilohertz, which is called as the supra-order harmonics. You can also see harmonics between the orders, which is called the interharmonics. So it's a very big topic. So we have all this in our presentations, but today we are not covering it. But if you're interested, you can follow us, you can discuss with us, we can give you more education, deep diving on harmonics, because we can talk days together on this topic. But this is something what happens in your network. Then you also have the reactive power, which is the power factor problem, or from the linear loads, as I explained to you. And also you have the network unbalance. Then you can find voltage variations, dip, sags, swells. Resonance is a very common phenomena today. So you know every network has a resonance, but the severity of the resonance depends upon the failure of your system. So if it is very severe, the systems can fail. It can happen in just a fraction of a second and go. Then you have flickers, which can happen in your industries, then transients. So these are the typical power quality problems what you can face. And in all these scenarios, Comsys has a solution called active dynamic filter technology, which can solve all these problems in low and medium voltage. When I talk about low voltage, we talk till 690 volt. When we talk about medium voltage, it's all the way up to 132 kilovolt. Right. Now, what is this technology and what do we do? So I will explain what is ADF, active dynamic filter technology here. Here you can see a medium voltage grid. So this is your typical distribution, and this is your transformer where you have your primary, it's a medium voltage, then you have your secondary, low voltage, and you have this bus, 400 volt bus example, and you have all your linear and non-linear loads distributed here. So you will have the further LED lights, UPSs, or your coffee machines, your chillers, anything can distribute on this bus under this trafo. So what happens here is when you drive this with the VFDs, as I said, you no longer have the power factor problem, but you will have start harmonics adding together from all the non-linear loads and goes to the source. On the other hand, when you have a linear load, if it's a mixture of load on your trafo, on the linear loads, it can create the inductive reactive power, and it can also come like this on the system. So overall, it gives you a distorted wave and it goes all the way up to the top. Now, what is ADF and where it comes? So ADF is a very high-end technology, high-end active technology. So this comes in parallel to the complete load. So ADF is always installed in parallel to the complete load, addressing the whole system. So it comes on the PCC. We call this as the PCC, point of common coupling, and this addresses the whole load in total. ADF has two important components in this technology. One is the main controller, which is the brain of the system, and another one is the power module, which is the muscle of the system. So when you get a distorted wave here, we sense this wave into the controller of the ADF, and this controller decodes these harmonic currents and tells this power module to counterfire the opposite of these currents to the grid. So when it sees a harmonics at certain frequency, for example 300 hertz, which is your impure current or unwanted current, the ADF controller will counterfire the opposite of that current to the grid on that particular frequency. So when you get the opposite current, it makes your current clean and you get a clean sine wave all to the top to the trafo. So as I said, when you have a bad current distortion, or the current harmonics, you will have problems at the trafo, which is already saved. When you solve the current and voltage harmonics here, at this point, using the counter technology, when the voltage is solved here, the voltage is solved here, the voltage is solved here, and voltage is solved at all your loads, because the voltage at every parallel node is the same. If you have a problem of voltage here, you have a problem of voltage here, you have a problem of voltage here. So it's all solved everywhere here. So this is the ideal way to solve it at the PCC, because you solve both the current and the voltage, and you save the loads and you save the transformers. That is why today almost all the standards, every standards, for example for the power quality, talks about solving this at the PCC, point of common coupling. This is the main reason of doing that. So so this is the technology of ADF. It's in a block diagram. If you have to see this, you have a distorted current from the load, and ADF comprises of a power module and a controller, and it counterfires the opposite of that distortion current, and you get a clean sine wave to the source. So this is how generally the principal working of the ADF technology inside. Now, it's good to know, as I said, the drives, VFDs are the main source of harmonics in your network, but there are also other types of loads today emerging because more and more electronics are there in your systems today. Apart from VFDs, I see EC fans, which is commonly used now, generating different kind of harmonic profile. LEDs, a good amount of LEDs in almost every installations, which will create a lot of harmonics. Then you have non-AFE type UPSs, wherever there are rectifications, screens, these can all create harmonics. But typically, if you take an industry, the VFDs or the variable frequency drives, which are used for the energy saving purpose, are the major element for creating the harmonics. So you see here, the VFDs create around 35 to 100% of harmonics, which you have to be aware about. It depends on the VFD. Any kind of 6 pulse standard VFDs, which uses a diode rectifier. This is the rectifying part, which is the diode based. Then you have a DC, common DC. Then you have the inverter, which is IGBT based. What you say, this is a standard arrangement of a 6 pulse rectifier based VFDs. This can create around 35 to 100% of harmonics with and without choke. So if you have a line reactor or a line choke at the input of the drive or a DC inbuilt reactor, this can restrict around 30-35% of harmonics. If you do not have it, it goes to 100% of harmonics, and it's not even good for your rectifier. So we always recommend when you select your VFDs, at least select with an inbuilt choke or a line reactor. Maybe the small drives comes with an inbuilt choke, so it suppresses your harmonics up to around 30-35%, and the rest you can bring it down to your limits as specified by the various standards. So when all these VFDs works, it generates this amount of harmonics in current basically, and it adds up and it comes to your source. Now there are VFDs available in the market which call it as low harmonic VFDs or active front-end VFDs. So I already showed you the arrangement of a VFD where you have this diode based rectifier, then a DC, then you have the inverter IGBT based. So when this front end is diode based, that's called the 6 pulse VFDs, which is most commonly used and which is 98% efficient. What you see from any manufacturers, it's 97.5 to 98% efficient, which is the maximum used and the best VFDs to use because it has a very good efficiency. When you change this front end to an IGBT based front end, like what you see here, it's a low harmonic drive. So the drive will not generate harmonics when you change this front end to this. So the technology what we are giving as an ADF active dynamic filter is the same thing using an active system. So this is called as active front end. We call it as active dynamic filter. So it's the same technology using the fastest devices called the IGBTs for switching. And the only difference what we make is we give it separate as a separate system, which gives you a lot of advantages in terms of many things. So if you integrate this module to this system, it becomes a low harmonic drive. You can very well connect this to the system, making it as a low harmonic panel. You can connect the flexibility of this module is to connect on the MCC, then it makes it a low harmonic MCC panel. You can also connect it on the PCC, so it becomes a whole system as a low harmonic. We would suggest this because the standards in the world talks about a PCC solution mitigating the harmonics. I would say why, what are the advantages in a nutshell. So when you try to integrate it here like this, the first biggest drawback what you have is this is in a series connection. So you are integrating it to your drive. So you are involved in the process totally. So if something happens here, your process is cut down. So probably if this is a very crucial process and if the front end goes, then your process completely stops. And the production loss is something what you cannot quantify today because it can be in millions, it can be in trillions, it can be in billions. So it's very important to have a parallel connection like this. So if something happens here, your process is intact and there is no problem on your process at all. That's the first biggest advantage. Second, it's a very costly solution. You know that AFEs compared low harmonic drive compared to a normal VFD, it's double the cost or more than that cost because you are integrating the latest technology into the drive. Same like ADF. And it's also when you integrate that, it becomes the system much bulkier than a normal VFD solution. So you have a bigger footprint. So bigger footprint is bigger space and bigger money. You pay on square feet. So it's a bigger footprint what you have to use it for the AFE. It becomes the system more complex. Now, when you try to integrate this like this, another biggest drawback what you find here is the losses. So if you compare the losses on a normal 6 pulse VFDs, which is around 98%, 97.5% efficient, the AFEs will have much lower efficiency because the IGBT switching losses gets added into all your feeders. So it can be probably in the range of 94-95% efficient, which will induce additional 3 to 4% losses to your network. So I just did a comparison here. You can have this calculation depending upon your project or your plant, approximate calculation. ADF has an efficiency around 97 to 97.5, which is in the common, and you are connecting it to a common VFDs around 4 or 5. total load of 1000 kilowatt here running for 1 year, as against individual AFEs or low harmonic drives contributing to total 1000 kilowatt. And you see a difference in the energy. Right now I have calculated here as an energy price of 0.06 euro per kilowatt hour. Right now the energy prices are quite high here. It's 10 times higher than this. You can see what is there in Saudi right now, and we can share you this calculation. And you can see for 1000 kilowatt in the old energy price, I could see a difference of 15,000 euros in an year if you run the whole system on AFE. That means the running cost of AFE is the energy which it consumes when it runs is much higher than, and this configuration giving you the same result and the same technology. And this will be much higher when you change the energy price and when you change the kilowatt based on your loading system or your factory. This is very important to know. So the operating cost is very high. The installation cost is very high. The footprint is very high. According to that, you would need higher breakers, cabling, installations. So these are in a crux what I can give you a difference between the same solution implemented at the PCC as against the same solution implemented on feeder level. This is one of the reason now we should look at what is IEEE 519 talking about. So you know there are various standards in the world. Comsys is present in more than 50 countries, and we talk about almost every standards day in day out. We cater to the Korean markets with their Korean classification. We have markets in UK. We talk about G54 there. We have European as our biggest market where we have EN standards there. But I believe the Middle East follows IEEE standards there. And one of the reason why IEEE is also talking about a PCC solution is because of that. So all these standards what today sizes the systems on the PCC, point of common coupling. So the point of common coupling will handle the whole load under the traffic together, and you can do the mitigation at this point instead of doing at the load side. Of course, if you can do it at the load side. There is no problem in that, but the standard doesn't say so because you are adding the hardware, you are adding the losses, you are adding many other things which I already spoke about, the running cost, the capex as well as the opex. Right. Now I get specifications from the Saudi market talking about I want harmonics THDI levels to 5% and also as a low harmonic drive. So as I explained you, what is the difference between a low harmonic drive and our technology, which is efficient. We would like to address this market with the most economic way the customer gets benefited. Now, when you talk about a low harmonic drive on an IEEE 519, it never suggests that the drive has to be low harmonic. It has to be on the system level. That is what is shown in this table. And I also get requests that we need THDI 5%. So IEEE 519 never talks about 5% in total all the time on the current. It talks about 8% on the voltage. This is the latest standard, 2014. And in the current, you can have 5%, you can have 8%, you can have 12%, you can even have 20%, depending upon the loading or the transformer short circuit ratio what you have in your network. So if your short circuit to the load, the ratio is very high, that means you have a lesser load on your trafo, you have very good room in your trafo. I mean, you have the capacity of the trafo to absorb the harmonics. You can very well have a higher amount of harmonics flowing in your network. That means if you say 5% means the 5% of the harmonic current out of your total current is allowed in your network. Suppose your total current is 1000 ampere and 5% of that is 50 ampere. So that means 50 ampere is allowed. You don't have to have zero harmonics. Now, when you try to do it on the drive level or by a low harmonic drive, what happens is by default, you are making the system to 5%. That means you have added more hardware internally to make it to 5% by default, where you would probably need only 12%, which is good for your system. No systems are loaded fully. You will definitely have some safety factor calculator on your transformers. So on the other hand, when you try to make low harmonic drive, you are actually adding the cost of the project with no reason and no other benefit. And you are trying to make it to 5% all the time. Maybe 8% could be good enough in that short circuit ratio. So that's also good to know. It's not always 5%. It can have different various TDD percentages. TDD equals THDI in the full load condition. So IEEE always talk about TDD scenarios. We can talk in detail, but this is the brief what you should know about the PCC solutions and also the standards, which is talking about what level of harmonics the systems can absorb. Okay, now coming to the active dynamic filter technology or active filters in general, there are many things which you can compare between the brands who are claiming they have filters and solutions similar to this. You can talk about the ambient temperature, you can talk about their engineering, you can talk about their performance, their type testing, their CE approvals, and various other factors. We can discuss in detail. We have enough documents for that. But one thing I wanted to highlight in this presentation is that the 100 ampere of active filter of one make is not equal to the 100 ampere of active filter of other make, unlike drives or switchgear, what you select it on the rating. Because as I explained you, the functioning of the active filter or the counter firing is happening on very higher frequencies because the harmonics are present in those frequencies. Now here you see on the x-axis, you can see the harmonic orders. So when I say 3, that means 3 times 60, it's a 180 hertz. 5 means 5 times 60, it's the 300 hertz. And these are the harmonic orders, what you see all the way up to 49th. And this is the curve, what you see for the Comsys ADF P300 is our product line, and how much it can counterfire on each frequencies. And typically the VFDs create 5, 7, 11, 13 as a three-phase harmonics, what you see in your network. So it's very important to mitigate 5 and 7 completely, then you will be in the target level as per IEEE 519. So here what you see here, Comsys has the capacity to counterfire the same amount of current till the 7th order of harmonic. So if you see 100 ampere of harmonic on the 7th order, you can counterfire minus 100 amps without any duration. But if you see some current on the 11th order, Comsys filters will have a 20% duration. So I would probably need 120 amps to counterfire that. So all this put together is your rating of the active filter, which you call it as 100 amps or 200 amps. That's how you size the systems. Now let's see what happens to an X brand. So another brand, what we have tested here, what we see here is there are high durations happening from the 5th order of harmonic, and it goes very, very high all the way when you try to mitigate the higher frequency order harmonics. So intact, if you see here on the 7th, when Comsys tries to do with 100 amps, this will probably require 135 amps. So when you need more current, it ultimately gives you more space, more size, more ratings, more losses, more cost, everything gets added, more switch gear, more cables, more commissioning, more complex, all those things gets added. Let's see why. Y also has a duration. It starts from the fundamental frequency and it goes like this, and you would not see any output beyond that. So the basic filter should be capable of handling up to 49th order, which is the IEEE standard. Then there are filters which can handle beyond that. We do have that solution. Let's see what Z is talking about. So Z also has a duration starting from the 5th order, and it has almost similar curve like X, and this is how it follows. So out of this, what I wanted to explain is if you are mitigating 100 amps of current in total, which has 91 on the 5th order, 33 on the 7th order, 24 on the 11th order, and 10 ampere on the 13th order, you see here the ADF, our technology can do with the same amount of current up till the 7th order. The X and Y would require 46 amps and 50 amps against 33. And here you see 53 and 62 against 30. So in total, 100 ampere of Comsys or 102 ampere of Comsys may be equal to 118 or 124 of some other makes to basically achieve the same result what you are sizing for. So what we have sized is not equal to something somebody else has sized. So it's very important to know, and derating can have a very big effect on the sizing, which will contribute again to high losses, high systems, high pricing, and more modules getting added to the system. Good. So I will touch upon the product range right now. So we have a huge product range. As I said, this is the only biggest product what we make. So we have starting from the smallest filter, ADF P25, all the way up to StatComs. We have new modules under release at the moment for Q4. So if you follow us on Comsys channel and Comsys on LinkedIn, you will find what is happening and what are the new modules, dynamic energy storage systems, DC solutions. Many upcoming releases are happening. So please do follow us. So you will find all these informations coming to you right away. So we have a big bunch of products here. Quickly on ADF P25 is our starting range of filter, which is a 30 ampere filter on 480 volt. So all our filters follows a standard dimension on the width, which is around 227 mm, which is very compact. So we follow a tall and sleek design. You know, the panel has a height, the ceiling has a height. So it's always good to have a compact product on the width rather than making it on the height. So if you have a more width, you consume more space. So all our modules starting from 30 ampere or 150 ampere will give you a very compact footprint of 227 mm, and this is a 30 ampere system. We have a patented technology called sensorless and also current control. So current control basically uses the CTs, and we have something called a sensorless control where we can mitigate without the CTs. So right till now we spoke about harmonics from the load. So suppose you have harmonics coming from your background or some other distortion coming from outside which is not in your control. There is no technology in the world which can do that, but we can address that using our technology called sensorless, which addresses the background distortion as well. So two features are available in the filters. It can at a time it can do all the three functionalities: harmonics up to the 49th, reactive power, which is the power factor, so you don't need the capacitor bank, and unbalanced. All the three functionalities together can be integrated and used simultaneously with this product. It works on web user interface, air cooled and wall mounted IP20 filters. You can parallel as many modules as you want depending upon your rate. This can be very good fit on an AHU or a small applications where you wanted to do it on some small drives of 10 numbers or 12 numbers on a small AHU panel. Coming to the next range, we have ADF P100, which is again the bigger rating. So here you have 50 ampere to 150 ampere modules in the same frame size, 227 mm in width, and you can parallel as much as you want. You also have the 690 volt, again the same frame, so it's again compact frame on 90 ampere, and you can parallel as much as you want. All our systems are type tested under CE with a very stringent type test in Sweden. Apart from that, we have various approvals on third-party stringent tests like DNV, Lloyd's, ABS, UL, and these kinds of tests. So you know, to clear all these kind of DNV, and these are very stringent process. So these filters are also having the certifications on these various standards as well. So the type test is well taken care before it's shipped out to the customers. These filters also take care without CT, called sensorless option, and with CTs. 3-wire wall mounted. You can also put it in the cabinet, and it's air cooled version systems. It can address harmonics, reactive power, and unbalance at the same time. This filter can also be used for the flicker compensation. So as like harmonics, flickers also have standards in the world. So these filters are also capable of handling that. This is the 4-wire filter. So if you have neutral harmonics, which is created by the single phase source of harmonics, you can use the 4-wire systems. The features are the same, but it follows the same dimensions like the other model, what I showed you. It's wall mountable, IP20 and IP21 classification. Then we have the cabinet versions, which is type tested under UL, DNV, and CE. This is available in 360, 450, starting from 150 all the way up to 450 in the cabinets. You have different various IP classes like IP32, it starts with IP32, then you have IP43, then you have IP54 versions available for this filters. Approved at DNV Lloyd's, as I explained, features are the same. It can address 49th order of harmonic up till and reactive power and unbalance at the same time, uses CT control and also as sensorless an option, uses web user interface, air-cooled 3-wire version. You can parallel the cabinets as much as you want in this scenario as well. If you want a single module configuration on various IPs, 32, 43, or 54 on the cabinets, you have it on P300, 150 amps, 300 amps, 240 amps, up till 450 amps. So 3 module configuration, 2 module configuration, and single module configurations are also available in the cabinet versions in various IP classes, what I explained already, with all the approvals. We have this special filter. This is quite common these days to have the special filters for various applications. These are for brownfield projects where you have various issues like interharmonics or resonances. We see a lot of applications for these filters in those regions where you find a lot of heavy resonances in the network or harmonics beyond the 49th order. So this is a very special filter, and this is a very fastest filter, we call it as. It's called ADF P200. This can compensate up to 5 kilohertz of harmonics. It can also do the interharmonics between the harmonics. It can mitigate resonance. This is the only filter which can mitigate direct resonance on an active base into the systems. It's 480 volt. It works on sensorless and wideband compensation. So a very special filter. It's selected based on a very high quality measurement to determine if you have special failures and things like that due to resonances or high voltage distortions, which can be controlled by this filter. We also have solutions in medium voltage called the StatComs. We call it as dynamic reactive power compensation. It's called DES, or dynamic energy storage, where if you have problems on the medium voltage, example, you have very dynamic loads on the medium voltage, which is creating a high reactive power on the medium voltage, say 66 kV or 33 kilovolt, due to a high switching of maybe a inductive reactive furnace or an arc furnace, electric arc furnace, or various other dynamic applications which create a very high amount of reactive power, which is very dynamic and cannot be stabilized with a capacitor bank. So we have this called as StatComs, plug and play. You can order it in 2.5 MVAR and parallel to for 5 MVAR. It comes as a complete container. You can directly connect it to the 130 up till 132 kilovolt of systems. This we are calling it as ADF P700 StatCom solutions. We have a very beautiful options for the panel builders. If there are panel builders here, please feel free to send questions. I'm not looking at it right now, but if time is there, we can take some questions also in the chat. So this is a beautiful option for the panel builders where you get the power module separately and the controller separately, and you can use your cables and breakers and your normal power supplies and integrate it to your cabinet wherever you want it and in your name. You can build your own systems. So suppose you have a drive and you connect it parallel to the drive, it becomes a low harmonic panel. If you connect this module on your MCC, it becomes a low harmonic MCC. You can connect this module and parallel these modules in your PCC and make it on your main PCC panel. So you don't have to buy a standalone cabinet. So this is a type tested module, a power module, which is available between 50 and 150. You can choose among this. If your requirement is 300, you can have 2 power modules, use 1 controller and integrate it to your cabinet using our manual, using the local other switchgear and cables and CTs and things like that. So this is also type tested and approved under various standards. So you are not allowed to touch inside the power module. You are just integrating like a drive to your cabinet, and you can make your own low harmonic drive panel or low harmonic MCC or the PCC. And a very important thing to notice is that we have made our systems very sophisticated, very advanced, intelligent based. So this is controlled by the web user interface. So at any point of time, you do not have to install any software in your laptop and take it to the site. You can take whatever laptop available in the site, connect an Ethernet cable to the filters, open the Google Chrome and type your IP address. You have the access to all the screens and very high sophisticated software. You will find all these harmonics, and you can put the compensation settings there, and you can just save it and start immediately. The harmonics comes down. This gives a biggest advantage because if you find any troubles and anything, you don't have to run to the site. You can immediately contact through the online. You can give the remote support. We can give the remote support. The service engineers come from Dash can give you remote support to your technicians, and technicians can itself solve the problem rather than waiting for the people to come. So most of the times we do the commissioning across the world sitting here if they have taken our services or our partners does across the world, the first level is always doing that. And most of the times, not any time, you have to send the filters back to any service center, because these are modular systems. If there is any problem of time, any failures on any components, it's also replaceable. So this is designed to work for 10 years and things like that is our basic idea, to give a very robust system into the network. So you have the login facilities in the filter. You can get the log files automatically. You will come to know what really happened in your network, and in the remote you can share it with us, and we can scan and see what all things has gone wrong in the network. Is there a dead short circuit, or all these things are captured at every second inside the log files. It's a very good feature and can be connected from anywhere in the world. If you put it into your network, you can even access the system. So all the systems by default, free of cost, comes with this feature of web user interface. Right, now that's about the product and the features. Now, as Comsys, we also support our partners and customers to determine how you want to select the filters in terms of your projects. So there are two ways of doing it. Dash is fully equipped with their engineers to support you. So they have a team where they can come to your plant if it's an existing plant, if you wanted to have some kind of analysis, if you have a failure, what has to be done, if you have a regular harmonics from the drives and if you have to comply with IEEE 519, what has to be done. They have various measuring instruments. Their team can come and do the measurements to you, and they share it with us if it's very critical. Otherwise, we give the suggestions and they can size the filter for you if there is an existing plant where you have a lot of harmonics. On the other side, we support with a lot of tools to our partners and the customers. And one of this is our online sizing tool, where you can simulate the harmonics available in your network on a greenfield basis. So if you're designing a project and if you have the SLD, if you know what is the source and what are the loads under that trafo, if you key it into our software, you can design the harmonic spectrum. You can get a simulation, what are the harmonics expected in what are frequencies, and what are the filters and what standards to comply with, and things like that. So this is also available with Dash. They can support you with the calculations. If you have a greenfield project where you wanted to use our systems and simulate it, changing from a low harmonic drive, or get a better understanding or a better design of the systems in terms of operating cost and capex, they can help you to design the whole system and design the filter at the PCC for you. So here what you have to do is you have to know what is your trafo, 2000 kVA, which caters your whole loads, impedance of the trafo and the voltage level and the frequencies, 50 or 60 hertz, south is 60 hertz. Then important to know is your loads, how many VFDs are there, nonlinear VFDs or low harmonic drives, which are actually active. You don't have to add the standby loads like in low harmonic drive, because standbys will never create a harmonics. If the duty is failing, then only the standbys are coming into picture. So at any point of time, our design will be what the harmonics are created. So you can always have the standby loads not into the tool, only the duty loads and their loading pattern and what is the DC or AC choke available in the loads. You can club it and put it as a whole, like 1000 kilowatt, what you see here, or you can have individual drives as well. And what are the other linear loads? For example, you have a DOL starting or direct online starting, star delta starting, or soft starters can also come into the tool with a power factor. Then that's all what we needed. And when you just submit it, when you submit it, you will find the spectrum generated based on the inputs what you have given. The before, what will be the harmonics in each order. So depending upon that input, you will find harmonics in the 5th, 7th, 11th, 19th. These are the harmonic currents which you have to eliminate. And you need to do these settings in the ADF. And this is the size of the ADF. So you will have a spectrum before the compensation. You have a total current of 1147 amps, out of which you have the 322 amps. And to bring it down, you have a THDI of 29% here and the voltage at 8%. And here you have selected the target as IEEE 519. So you have the options to select which all targets you want on IEEE 519 or EN standards or G54. So here what we have done is we have selected the auto So it selects based on the short circuit ratio. Here you see the short circuit ratio was less than 20. If you remember the chart of IEEE which I showed you, so it has to meet 5% here, and it's the system automatically selected based on 5%, and it will bring down to 5%, and you need 470 ampere of systems to do that. Now the power factor displacement is quite good because it was only drives 0.96. As I explained you, drives will have a good power factor. If you have more linear loads, you will have a bad power factor. So remember, when you install more and more capacitor banks, it's not needed when you have more drives in operation than the linear loads. But if you have a combination, and if you wanted to also, if the power factor was bad here and if you wanted to correct it, you also have the option in the tool to activate that. Then the filter will probably give you 520 amps or something, and you can also make this power factor to 1. Both the functionalities together, you can size it. So this is the feature. This is a tool. It's online. We give it to the partners. They can support you. If you have a project in Greenfield, only thing you should know is you should consolidate these loads under the trafo and give us this information so they can consolidate and give you the right picture what to select on the filter size. Then you can choose whether you want a cabinet or you wanted a module to integrate it into your PCC or MCC, or you wanted a wall mounted version, or whichever versions are available with us. So overall, to summarize, ADF, complete product, manufactured, engineered, type tested in Sweden, strong focus. This is the only focus. So we talk about the same subject, application knowledge. Yeah, this is the only topic what we discuss day in, day out with our partners. Very good reach with our partner network. So you have partners around you where if you want support, or you can connect with us. So we support you with the technical and they support you with the other stuffs like installation and commercial stuffs. Very, very flexible. So it's very modular, scalable, flexible. You can put it anywhere, PCC, MCC, or standalone. You can scale it up tomorrow, parallel, 111, parallel each. Very compact to put it on the wall, on the cabinet. Yeah, so it's this is the summary of what I have today. So thank you very much. I think I'm on time, 1 hour. Sorry if I have a little fast because I had to cover these topics, but we can connect if you have any projects. If you wanted to have more discussions, Dash and myself, we will connect with you separately on a separate meeting. And when I'm visiting there, normally I visit. I have plans to come end of this month or next month. So if you have a serious projects to discuss, we can discuss together, we can visit you. Otherwise, Dash engineers are available. They're technically qualified, they're trained under Comsys, and they can come and also help you with the solutions. Right, that's all from my side. Thank you very much. So Alaa, we have any questions?
Yeah, wonderful. Yeah, we have two questions now from Engineer Muhammad Al-Drubi. Can you do harmonic study, or do you have an instrument to measure?
Yeah, that's answer for you because
Yeah, for sure. Yeah. We have full instrumentation, and we have a technical team and a specialized engineer for making the study of harmonic in Saudi Arabia, in Jeddah and Riyadh and Dammam. So whenever you want, we are ready, and our team are ready to do it. So usually we make the study and we make preparing a full report in case there is like a unique or a lot of technical details. Usually we contact with our partner, Mr. Paul and Comsys. So we have technical discussion to select the suitable solution from Comsys. Question number 2, can you connect many filters in parallel?
Yeah, that's what I said. So one filter, then you can parallel it as much as you want. So that's not a problem. That's the beauty of this solution. You can even install a filter without even calculating anything because it never overloads. So it will compensate based on its capacity. And if you want to, so you know that, okay, this is not good enough, then you can add the next module and parallel it. Yeah. So that's no problem.
Wonderful. Maybe just adding, Mr. Bor, regarding the modules, usually it should have the same current. So,
yes.
For example, if we will have parallel 150, that means the second should be 150.
150 right now.
Exactly. So for sure, that is one of the superior option for Comsys. And
Good.
that is just the only question. If there is any other question, we are ready.
Yeah, but you will get a recorded version here also and follow Comsys. So we have many more things getting launched in the next quarter. New modules coming into market, new versions, new with more and more efficient systems. And Dash is fully equipped now. So if you want separate discussions on your plant or your project, we are there, because we don't just suggest. Sometimes we always say you don't need filters, where others would have said that you need filters, because as I said, you don't always need 5%. That's not the rule, but we will help you what you really need, and that is where you will save your money. So let us know. Connect with Alaa and his team, and follow us on LinkedIn, and let's know if you have some more questions. Yeah, okay.
Thanks a lot.
Thank you
Thank
very
you.
much. So
Thank
have a
you.
nice day,
Thank
nice
you.
weekend to all KSA people. Thank you. Bye bye.
Thank you, bro. Thanks. Bye bye.